Recording. There we go. So, how is everybody today?
Great.
Good. Yeah, not doing too badly. All things being considered. So, today we will be talking about Unity, the Unity development environment, and we will see if we can get some stuff working today. There will be a quiz this week. The assessment that you are going to be required to complete will be a quiz, so please make sure that you come to class on Friday. We will have our quiz during our Friday class. Very low weight, very, low impact exercise, shall we say. That's a medical thing, right? Low impact exercise. So, this room doesn't have a podium. It's just this. Huh. Well, there you go. It's probably fine. So, Unity then. Unity is a development environment primarily for video games, but it can also it's also used as any kind of application where you want three-dimensional models interacting with the user, sort of interactive software type applications. There are lots of different applications that you can use Unity for, not just the video games. Just as there are many different applications that you can use video game-like technologies, but it's not actually a video game, right? One famous example of video games and virtual reality applications to the medical field. I'm not sure how widely this is spread at this point, but I remember that there were trials being run of putting VR headsets on patients who were being scanned in like a CT scanner or something like that, as kind of like a means of entertaining people while they're in the middle of some kind of medical test scan type thing, in order to keep people calm and still while they're being scanned. Not a bad idea. Another application that I've seen of this type of technology, video game style technology in the medical field, is that you can design a video game. Like, you don't just have to design a video game along like the principles of game development as they exist in that field. Some of these video game type exercises can be things like calming exercises, which people with particular types of afflictions, it might be useful for them to have a kind of exterior visual stimulus that helps them go through like a breathing exercise or something like that. These are the types of things you can use something like this for once you actually learn how to use it, which is the purpose of this class. So, let's get started. Any questions? Cool. Yes?
It's better to use one of these first.
Do you have Unity installed on yours?
No.
In that case, it's a big download, so I would recommend using the lab computers for today. I will show you what you need to download to get Unity up on your own machine, and then you can get squared away, but the lab computers already have it, so we might as well use it. So, Unity is a big, bulky download. I think it's something like 4 gigs or something like that. So it's too big to be effectively conveyed through Mohawk apps. So it's just been natively installed on the computers in the lab. If you hit the Windows thing, or I think just start typing, Unity, no, you haven't hit the Windows thing, Unity, you will see 2 things pop up. One is Unity, the application. The other is Unity Hub. You want to click Unity Hub. Unity Hub is an application which manages instances of Unity. You can have multiple versions of it installed on your computer at one time. And this is also how you manage your license for Unity. So, because it has detected that no license is available, it brings us to the new license page, or the no license page. We must now perform a license activation, but you will all need accounts. So, if you, is everybody at this screen? Put your hand up if you're not. Everybody got it? Sorry. Yeah, that's a fairly new version. This is an old monkey version. Yes. Yeah, that's the same thing. I recommend the actual install of Unity that you use. You match up the version to what we're going to be using in the lab, just for compatibility. Furthermore, yeah, that's just match the version number. So if you click on the little person icon, which the person icon looks less and less like a person as time goes on, I find. You know, if you click sign in, you will have this login thing, and you will need to probably create an account. So if you don't have a Unity ID, please create one. That will open up this screen. Your email, your school email is a fine one to use for this application. Pick a password, don't tell your friends. Pick a username and also specify a name. Click all the checkboxes. You've probably created accounts before. Once you've done that, log in with your newly created account. Put your hand up when you finish that. So yeah, confirm the email, yeah. Sorry? Oh, well. You should get started on that download. I'll show you which version we're using. it's 22.3.8F1.
That's the one, point three, yeah, that's the one, no, it's not the one, it's not the one.
You probably see 2023, right?
No, it's 2022, maybe this is just for the editor actually, it's 2022.3.45 F1. But that might just be the editor,
That'll be close enough.
but yeah, it does say 2022 on it, so.
Yeah, it'll, major updates are kind of on years, so it should be fine. It'll be close enough. Okay, so how are we doing with login? Logged in? Logged in, good. Are you logged in? Logged in?
I sent the email, but you guys think it's
Please call. It's not your,
So ID.
ID number does work, I believe. Both will work if you use the correct one, but if your name, it's like first name dot last name with a number, if somebody has had your same first name, last name combination before, that's how many times, that number appeared. That your number, that's like a count of the number of people who previously had your name, if that makes sense. But if you check your email and try to send an email to yourself, you should be able to get your profile on Outlook and then find your email that way. For the longest time, you weren't actually able to copy an email address in Outlook. Yeah. Like they added that this year. Okay. You guys in? You in? In? Okay, and yeah, I'm working on it. So if you go to, oh man. If you go to license management, you will see activate new license and manual activation. If you click on activate new license, it asks you if you want the free one or the one you pay for. You want the free one. The company or organization I represent earned less than $100,000 in gross revenue in the previous financial fiscal year. Probably not. You probably want to pick, I don't use Unity in a professional capacity. There you go. Once you have that, you now have an active license, so you can actually use Unity. Now, oh, sorry. So you're in settings. If you click the little arrow up by preferences, that will get you back to the main menu. So in the main menu, you have projects, learn, community, and installs. Our installation, right here, should be 2022.3.8 F1. So, anybody not see that? All good? Oh, you have a problem? Oh, back. Installs. There it is. You're welcome. So, we now create a new project. Go to projects. You have no project here. Dismiss. There we go. Create a new project. You get a dialog box. 2D, 3D, or 2D URP. Now, it's worth noting that you can do 3D stuff in 2D mode and 2D stuff in 3D mode, but generally it just makes your life easier if you pick one and stick to it. For our purposes, we shall choose 3D mode for our first project, and you can give it a project name, such as Baby's First Unity Project. Create. And now we talk about the weather for 5 minutes while Unity loads. Did you get everything squared away? I heard it's supposed to be hot this week. Yeah, is it too cold? Well, I mean,
It's very unpredictable. They said it will snow. I don't know.
no, we shouldn't get snow yet. Unlikely. Probably won't see snow till like late November, yeah, at the earliest. Usually, like maybe in mid-December before you get snow around these places. Oh yeah, yeah. So Canada is a big place, and we get news from very parts of it that are a lot further north than here. You are actually living in a part of Canada which is known in the area as the Banana Belt.
Why is that?
It's like one of the few regions in Canada that you can grow fruit.
But not banana. I don't
Not bananas, no. But like peaches and stuff. Yeah, but just like basically the area from Hamilton through to like Grimsby, through to the Niagara region is warmer usually than the rest of the surrounding regions. This is mostly due to the effect of the lake. The lake acts as a very, very large heat reservoir and keeps us warmer through the winter than most other parts of Ontario. So, yeah. That being said, you're new to Canada?
Yeah, it's
Yeah.
7 months.
Yeah. Have you had one of our winters yet?
No?
No.
I came the beginning of February, which they said is not winter. They said it's particularly, I don't know, spring.
Oh. Well, I don't know. I think February is winter. Yeah. Like it's not January, but it's still pretty cold.
It was cold in April.
Yeah.
Snow.
You have a good coat?
Well, not much snow. I'm not a winter person. I came
Yeah.
from a warm place, so.
Yeah. My recommendation: get a good coat, get good boots. Here we are. So, this is like, I don't know. This is like my like farmer hindbrain from all of the generations that my family were farmers. But I think it's going to be a cold winter this year. It feels like it's going to be a cold one this year. Anyway, so this is Unity. This is your development environment. Let us study the anatomy of this software. So, first and foremost, this is the scene viewer. All of the game objects which you will be changing, manipulating, working with are visually displayed here. This is your working view of it. If you see up here, you have a tab, which is the Game tab. The Game tab is the view through the game's primary camera. So inside of the game environment, there is an object called a camera, and the purpose of the camera is to look at things. It is to grab a region of the game and render it as the view that you see in the game itself, right? So this is the view through the main camera. The game view and the scene view are not the same view unless you like line up the scene view to be right inside of the main camera, which I don't know why you would. For example, if I drop in a very simple game object, go to Game Object, 3D Object, Cube, there you go. We get a cube at location 0, 0, 0. If we take a look through the scene view, you can see that here's our object. We have lines intersecting it. This plane is the floor plane of the view. You know, x and y are variable, but z is, or no, x and z are variable, but y is held constant in this plane. If we take a look through the camera, you can see that we are looking straight on one side of this cube. In Unity, if you click and drag on the tab, you can actually move this thing around. So let's just do a side-by-side view. And that gives us a pretty good impression of what's going on. Does this make sense so far? Good. This pane here, the hierarchy, is very important. This gives you a list of all of the game objects which exist in the scene. So, we have, right now, our main camera, a light source, and the cube that we just added. Game objects are hierarchical. You can have game objects which are sub-objects of other game objects. That's why this is called the hierarchy view. And if you're working with a game, I'm just going to call it a game, even if you're not using it for game. If you're talking about a game that has multiple scenes, you will have multiple scenes in this hierarchy view as well. So a scene is a screen, or a level, or a menu, or the title menu, or the high scoreboard. Anything where you don't need, like anytime you want to, just do this part of it, and then transition into it, and then transition out of it when you're done, that's a scene. In a puzzle game where you complete levels, each level you reset the scene to be the new puzzle at the beginning. Does that make sense so far? Good. So, this pane over here is the inspector pane. This is the pane that you will probably actually devote most of your attention to. This is where you modify properties of the game objects which are in your scene. So, if you select one by clicking on it in the hierarchy or clicking on it inside of the scene view, you will see all of the properties of this object listed for your, so you can read them and manipulate them. Make sense? So, game objects in Unity, it's the fundamental building block of the software. Everything in the scene is a game object. Game objects acquire different functions through attaching components. So, without these components, this cube is not a cube. It's just a blank game object. can actually create blank game objects too. Create empty game object, call it, I don't know, Bob. Good name for a game object. And you can see that we have an empty game object with no components. Well, not entirely true. We do have one component by default in every game object. The transform. The transform gives the game objects location, rotation, and scaling in world space. So you can see this new game object that I just created is located at 0, 0, 0, no rotation, all scaled to 1. If we look at the cube, we will find the same transform characteristics. So, if you want to modify a characteristic, you have two ways of going about it. First, you can just directly modify the attribute. I now have a cube at y level 4 as opposed to at y level 0. The other way you can do it is by clicking on the attribute itself and dragging, which, is also useful. You can do the same thing using the arrow widget inside of the scene view if you prefer things to be a little more tactile. Personally, I find this the easiest way to do it. It can get confusing in 3D space if you're trying to do precise positioning. Being able to control it from here is essential. Like, if I pull it this way, and I pull it this way, and I pull it this way, right? The positions of these two cubes relative to each other, it makes it like they're positioned such that they look like they're in line along the z-axis, and that one is slightly larger than the other, right? But these cubes are actually the same size. And you'll see that if you pop it into, if you pop the view into, what's it called? Orthographic mode as opposed to perspective mode. Right now this is in perspective mode. See this? You see this widget right here at the top? If you click around this, this allows you to manipulate the scene camera. If you click the middle of it, it will pop you from zip. There we go. From orthographic mode, or from perspective mode to orthographic mode. That removes perspective, and now you can easily see that these two cubes are actually the same size in absolute terms. Is this making sense? Question?
So there's perspective and then there's ISO.
Oh, yes. Isometric. Yeah, sorry. Isometric. But still, even in isometric mode, it looks like these things are lined up along the z-axis, but viewing things in the camera view of the game, we're getting a different picture, right? So, if you click on any of these cones, you can have top, bottom, side views of what you're doing. You can also manipulate rotation manually relative to the camera by holding down the right mouse button and dragging around. Panning is middle click with the mouse wheel. Scrolling, or zooming is with the scroll wheel. So you can kind of manipulate yourself around to put things in perspective, which you will often have to do, but just keep in mind that your widget is always available to you as well. Question?
Focus on an object.
Yeah. Double clicking on an object in the hierarchy brings it up close into focus. Places it at the center of the camera. Sorry, can you speak up a little? No, this is a blunder, unfortunately. I don't know, maybe it's got a mode for that. I don't know. So you have a tools palette right here as well, with a number of different functions. These are all for manipulating these properties essentially, but within the editor pane. So this is translate. This is the one we've been using so far. Rotate. You can rotate in any of the three main axes. Scaling. Also a useful thing to be able to do. And, various other things. Make sense? Okay. So far so good. Now, we're going to play with the physics engine just a little bit. So, in Unity, there's a fairly powerful physics engine built in which allows you to simulate the effects of physical forces on game objects. The system is composed of two main components. Number one, you have colliders. Colliders are a little bit like wireframes that you attach to an object that determine where its edges are. This does not have to line up with the rendered outline of the object, but for simple objects, it will. Not that we care about efficiency, but if you have a complicated model like a person, you don't render physics on every surface on the person. You approximate them as something like a capsule, and then, or a box, and then you do it that way because you reduce the amount of physics calculations you have to do by several hundredfold. Did you have a question?
No, you answered.
Okay, cool. So, did these guys come with colliders? Yeah. So the box object that is produced by default with Unity already has the collider attached. Collider right here. You can activate and deactivate components with the little checkbox here in the title of it. Boop. And it's kind of hard to see because it's just a line, but the thing that's doing is it's highlighting and de-highlighting the edges in green. In Unity, green lines are colliders. Make sense? So this thing has a collider, and this thing will have a collider. Okay, sure. That's component number one. Component number two is the rigid body, as in rigid body motion, the equations of rigid body motion. So what does it mean that it's a rigid body? It means that we're not simulating deformation, right? That's actually quite a complicated thing to do, and when a physics engine does deformation simulations, that's like a selling point on the website and that type of thing, right? So the rigid body tells the game engine, this is an object which I want to simulate motion on. So these guys are just hanging in space until we make them rigid bodies. At that point, they get physics calculations applied. So let's make one of these a rigid body and the other not so much. There we go. I have selected one of my cubes. You click Add Component, Physics, Rigid Body. There we go. We don't have to worry about modifying any of the components here, but mass is used to determine how much this thing can knock other things out of the way during collision. Drag will, it's a friction force which reduces velocity the faster it's going. Angular drag, the same but for rotation. You can enable and disable gravity, all kinds of things. In particular, you want to set interpolate to interpolate and collision detection to continuous. Just trust me, that helps. Just do that every time. Otherwise, you get a problem where objects will clip through other objects. You guys know what interpolation is? Heard the word before? No. So, if you have 2 points in space, you can, or even like points in like a data graph in like a statistics sense, right? You can draw a line between them because you know the 2 endpoints. This is called interpolation. If you then extend the line past the points, but it's still the same line, this is called extrapolation. Extrapolation is it's a term you're more likely to have heard. Anybody heard the term extrapolation before? I am extrapolating the data. That is to say, I am making predictions about the data that the data doesn't, like, the data suggests, but the data does not actually confirm, right? So, like, for example, if you are, oh, that is a terrible part. For example, where'd mine go? There it is. All right. If you're performing a study, for example, and you have a bunch of data points, ignore the ones that are dashes. Let's say you do a linear regression on the data. You guys have done linear regressions before, right? Good. Linear regression on the data. If you continue that trend line off into space where you don't actually have any data points, but you say, you know, if this bottom one is number of frogs, and this line is number of flies, right? Within this region, you can be fairly confident that the number of frog, like you have a fair amount of confidence about the number of frogs and the number of flies, be like you have X number of flies for Y number, or I should reverse that. You have Y number of flies for X number of frogs, right? Past about here, you don't actually have data on the number of flies versus frogs. For all you know, your data could go like that, right? Could be a runaway effect, or you could actually be in some kind of situation where the line will decrease after the point where you've measured. But if you extrapolate the trend as measured, you would predict a linear increase in the number of flies given the number of frogs. Right? So that's what extrapolation is in statistics. We use a similar idea here. Interpolation means if I have two objects and I have a barrier between, or if I have an object here and a barrier, and the object is traveling in this velocity so that in one frame it ends up here, if I'm not interpolating, I don't detect any intermediate points where I might intersect another object. But that gets a little, I guess we're getting into the weeds a little bit. So, anyway, this stuff gets math very quickly. So anyway, we attached the rigid body. We now have, like, the thing now does something. So I should show you how to run the simulation. Right there. That's how you run the simulation. Run, pause, skip. Or line by, like frame by frame. So, if you press play, it's going to take its sweet time, because this is the first time we've run the thing, so. There you go. The cube, what did it do? What did the cube do? Yes?
Gravity happened.
Gravity happened, yes. And why did it fall off screen?
Do you not have a floor made?
That's right. There is no ground. This plane here doesn't actually, like it's not a collider, it doesn't exist in space, it's just for reference. So we actually literally do have cubes floating in space. So, let's make the ground. Game object, 3D object, plane. Now, the default is for it to drop things in at the center point of the, like wherever the camera is focused. That's probably not where you want it. In our case, let's modify the position of the plane to 0, 0, 0. You may have noticed our plane also comes with a mesh collider, which provides this as a physics object which can collide with things. Note, it does not have physics calculations being performed on it, but it will interact with other things that do have physics calculations. So, what happens if we press play now? Oh. There you go. Not bad, right? Although, It's a little hard to see, right? Everything's just white on white. So, yes?
Line broke inside, like, down the ground.
Show me. Okay. Finally. Plane. Slider. Oh, you might have disabled it. Yeah. Or the box collider. So the cube doesn't have a collider, so it's not colliding with anything. Yeah, and you did a nice thing where like yours was slightly rotated, so when it falls, it tumbles a bit. Yeah. So I'm just for now going to show you how to add flat color to 3D objects. 3D objects have specified down here a material. You're the one who used Blender?
Yeah.
You are, yeah. This is probably going to be familiar to you. So, anybody else has anybody else done any 3D rendering in their time? Not even? Oh, that's okay. So what we need to do is we need to create a new material and attach it to the game objects. This brings in the other pane that I didn't talk about yet. This guy down here. This is your project pane. This is a view of your assets folder. When you create a new Unity project, there's a lot of stuff in there that you don't have to worry about. That's like its rendering engine and the standalone stuff to run the game. What you have to worry about primarily is the contents of assets. These are your game assets. And game assets are everything: images, sound, models, textures, materials, including scripts. When we start writing scripts for game objects, those will be assets in our asset folder. How are we doing so far? Are you guys following along okay? Can I get a thumbs up? Awesome. So, to create a new material asset, right-click inside of the project pane, create, material. You can see there's all kinds of interesting stuff in here, right? Scenes, Text Mesh Pro, playables, all the game objects I think you can create from this as well. Lighting setting, animation, audio mixer. At the moment, all we want is material. Not to be confused with physics material, though we may get to that later for fun. Material. New material, call this grass. When you highlight an asset in the project pane, you get a view of its properties in the inspector the same way as if you're modifying an asset out here. In this case, we want to turn it green. This is a color selector. If you double-click on the color selector, you have a choice of many different colors. You have a couple of other interesting properties as well, if you want. Smoothness and how metallic it is. So a metallic object looks like this. Basically, what metallic does is it increases the difference between like the highs and the lows on the shading, right? Makes it look shiny or more reflective. And smoothness, it affects surface scatter. So the more smooth, even if something's like highly reflective, if it's smooth, you won't get like that characteristic metallic look. But if you smooth it out, then it does start to look metallic. But this is grass. Grass is supposed to be, will have a matte color. There we go. Okay. Now, we need to apply this material to our ground object. That's very simple. You just drag and drop. Drag and drop. There you go. And now, there you have it. You can tell where the cube is. Although, perhaps another material, make it red, orangey red, there we go, and highly metallic. Works better with spheres. In fact, I'm going to delete that, add a sphere. There we go. Oh, yeah. Whoops. Need to add a rigid body. Now, a sphere isn't very interesting unless it's rolling, right? If you click on the plane and give it just a very slight rotation, down it goes. Why don't you guys take a couple of minutes and play around with it a little bit? And I'll come around and answer any questions.
Just curious, like right off the bat, does it feel kind of tension? We got the cube on, just the cube that's a little bit slide right now.
So
Or not
it
tension.
so friction force. It has default ones, but you attach right here a physics material to colliders, and that, let me show you, since you asked the question. If you create a physics material, here you go, physics material, you can modify dynamic friction, static friction, and the most fun of all of the physics parameters, bounciness. By the way, if you set bounciness to 1 or anything higher than 1, then the thing increases its velocity every time it hits something. Yeah, it'll go like boom, 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 and then it'll explode. It won't explode. It'll break the interpolation, and it's like its next frame will be so far outside the bounding box that you have it bouncing around in that it'll just fire itself off into infinity. And then, because of wraparound error, it will just eventually loop back around and hit again from the other side. So, actually, let's give it a bounciness of 0.6, which is fairly bouncy. Then, if we click on the object, click and drag the physics material onto the collider, boing boing. That's not bouncy enough. Let's make it even bouncier. Boing boing. Okay, I'm gonna apply that material to the mesh as well. Boing, boing, boing. There we go. If one half is bouncy and the other isn't, then, you know, so it goes. You had a question? All right. Let me just grab this. So, there's our 20. So, you might have some trouble already because I think that your cube is inside of your plane. There we go. Not about. See what happens. That's better. Now, to apply a material, first of all, this has got all of the default parameters already, so if you apply it, you're basically doing nothing. If you modify the color, clicking here, I'll make it maybe a nice teal. You'll see that it's modified the appearance, then you just click and drag onto the object you want to modify, and there you go. Does that make sense? Oh, yeah, I just rotated some points.
Oh, okay.
You can even do this while the simulation is running. So, yeah, it's just like, oh, that would be nice. It's not a lot, but it should start drifting. I think that it has tilted it towards the camera. Might be hard to keep up that far away from myself. There it goes. And you can see it's bouncing slightly higher each time.
Yeah.
That's like a fixed percentage of the total bounce height. And if you crank that up a little bit. Yeah, of course. Right click. Create. Make your modifications here. On the colliders, there is a material in here. You can either click this little target and then select that one. That'll lift it up, or you can like click or drag. We won't check this stuff. My next objective is to show you how to make this is going pretty well, I have to say. Like, this is one, I mean, like, people are actually accomplishing something here. There's normally classes. I'm happy. Very happy. You folks are bright. Oh, it's probably just on the wrong side of the plane. So, if you up to like a. Oh. Okay, that's an old one. So it might just be that the camera is not pointing, or it's obscured by the plane. So these rays here, that's the view of the camera. So you're getting like this edge of the plane, but if you just pull this guy up, yeah, there it goes. Okay. So right click, create physics material. Those are your physics parameters. And then under the collider, you none for physics material. Put that, modify that. Now, and this is for both of you. I only put the physics material on your rigid body object. If you want full bounces, you have to put it on the plane too. Because right now it's only half bounce. It's like a rubber ball hitting a shag carpet. It will bounce a little bit, but it's not because of the shag carpet. Having fun? Good. Okay. You want to know what's fun? Take two planes that sort of go like this in a V, and then put a bunch of balls in and watch them hit each other as they go down. Oh, yes, questions?
You kind of saying here is
Change the characters? You mean you mean like fix the view? So that's because of the positioning of the camera. You have two options, either move the camera or move all of the objects in the frame. But in this case, I'd say moving the camera is probably correct. So if you take a look here, you can kind of rotate things around so that the scene view is looking at where the camera is looking. So you see these lines coming out? Those are that's the extent of the view that the camera is rendering. So if you move it over this way, see, centers it here. And you can either move it down until things are in frame, or you can also you can also rotate the camera down so that way you get more of like a top kind of view. Yeah. But those are your main ways. I think that's better. Cool. All right. Enough fun. Now we must do programming. So, scripting. Unity uses C# as a scripting language. This is the same C# that we were playing around with last time. In Unity, a C# script is a component of a game object the same way that Mesh Renderer or Mesh Collider or the Transform are components of a game object. So when we want to add a script to a game object, we start by adding a component. If you scroll down to the bottom, you will see new script. You give it a name. I guess this is the plain, so round script. It then produces the script. The script does nothing. It has nothing in it except for its own default boilerplate stuff that it has by default. You will notice as well, by creating the new script here, Unity has automatically added a new script to our assets. Very nice. If you are doing any kind of project of any size, I highly recommend making folders in the assets pane for all of your different type of assets and putting things in folders so that they're nicely organized. You can get a lot of assets in these things, right? So, if we double click, it starts opening Microsoft Visual Studio. For your installation on your own laptop, it'll probably use whatever editor has been hooked up by default. If you want to open it in your own editor, you can...
He's trying to open up Visual Studio.
Okay, it'll work out. Let me show you all this though. This is really just a Windows Explorer pane right here, but if you want actual Windows Explorer, if you right-click in the Assets pane and say Show in Explorer, it will open up the actual literal... There it is. There's the Assets folder. You can go in, take a look. There's all the stuff that we have, and plus a little bit extra besides. First of all, because this is Windows Explorer, it will get some of the the file extensions wrong. So Grass is like, it thinks it's Microsoft Access, but that's because it's actually a .mat extension, which is used by Microsoft Access apparently. So like, you know, the file associations won't be correct in many cases, but you know, we are computers professionals. We are not thwarted by such petty concerns as file extensions. File extensions are mostly fake anyways. By the way, view, file name extensions. You should always have that clicked when you're using Windows. And you're a person who works with software or anything, really. If you're not a normie, you should be viewing your file extensions. So, you'll notice that we not only have all of the assets that we have in our pane, we have a bunch of meta files as well. These meta files are basically Unity doing some bookkeeping on your assets, tabulating them, keeping some information. You really don't have to worry about them. If they accidentally get deleted, Unity will regenerate them. They're just files, don't worry about them. Okay? So, you can also modify your script. You can like right-click this, open with, you know, choose your editor of choice if you don't like Visual Studio. So, yeah. But anyway, Visual Studio. Skip. Start. So, traditionally, this either works immediately or you try relaunching it and then it'll do it. It worked, good. Like, you can relaunch it while having another instance of it stuck forever on its loading screen, and that works. that's a workaround. So, I don't care what's new. Gonna try re-clicking on it anyways. There you go. Alright. So, this is the script as created. Don't panic. I know there's a lot of words on the screen. You don't have to know what all of them mean, but by the end of the course you should know what most of them mean. So, let's go through it in detail. These 3 lines at the top are called import statements. The purpose of these statements is to tell this script it's using other software from somewhere else, and this is where. So Unity Engine is a library. It contains a bunch of definitions which we are using. If we deleted that line, we wouldn't know we would be using definitions we wouldn't know like where they were coming from, and it would give you an error saying, I don't know what start means, because start is defined here. Make sense? So just don't worry about these, just leave them as they are and everything will be happy. Okay? So, number 2. Public class ground script, mono behavior. We're not quite there yet, because we haven't talked about object-oriented programming at all yet, and this is a class definition line. So, in object-oriented programming, a class defines a segment of software. An object is created from a class. So, for example, if I had a class named cats, that would define the properties and actions of a cat. That's different from my cat, Mr. Whiskers, right? Mr. Whiskers is a particular cat with particular properties. Mr. Whiskers has a location in space, a coat color, whiskers of such and such a length. That's why we call him Mr. Whiskers. All of these physical properties of the cat are what define the particular instance of the cat. But by examining all cats in existence, we can come to, or perhaps just a plurality of cats, we can come to conclusions about what the general properties of a cat are. Right? In object-oriented programming, the concept of the cat itself is the class. But any particular cat that has been defined from that concept is an object. So when we say object-oriented programming, the word class is as important as the word object. We will have time in the future to discuss this again. But in contrast to the examples we were doing earlier, we now have everything we do being done inside of a class. So all of the work we are to perform, all of the programming, will happen in here. Sound good? All right, now, start and update. Start is called before the first frame updates. So first of all, these two lines make this a comment line. Did we talk about comments? Yeah, okay, good. So that's a comment, it's just describing what this thing is doing. The start method is where you put your code if you want that code to execute once at the beginning of the program. The program here being defined as the lifespan of the game object the script is attached to. But again, we don't have to worry about that too much just yet. Number 2, update. Update is called once per frame. Do you folks know what a frame is? Anybody care to define it for me? What's a frame?
My understanding, like in a game, you run on like frames per second. So if you're looking at the screen, it's showing 30 pictures a second as times 2. Typically it's like 60 these days.
Yes. That's what you were going to say.
Says
Yeah. So this is like the oldest trick. This is the old trick in animation, right? When something is animated, you are showing a series of pictures which are very slightly modified from each other, which taken together give the impression of movement. But it is just composed of a series of static frames. The purpose of the video game is to render all of these frames based on physics calculations and movements of objects in virtual space and all of that stuff. It's to calculate what these frames should look like, play them in sequence, and or put them up as you're rendering them. Hopefully you're rendering them fast enough, otherwise you get frame rate dips. And you're right, 60 frames per second is the appropriate number of frames per second. Actually, it's kind of interesting. There was a number of years ago, maybe 10 years ago, the amount of like realistic rendering that video games wanted to do was outstripping the abilities of the hardware. So they tried doing 30 frames per second on video games for a while. This was generally regarded as stupid because video games require fast reaction times. At the time, the term they came up for this was cinematic, which is actually kind of interesting because I believe if you go to a movie and like watch a movie, I believe it's 24 frames per second that the movie's rendered at. But if you watch something on television, I think it's closer, it might be like 45 or 60 frames for like a television program, which is interesting because like over time people have become trained to think that fewer frames per second represent higher quality content because they have to pay to get in to see it. Whereas like if you're watching, your mother's soap opera on daytime television, which is being shot at like twice the frame rate, for some reason people think that's a lower quality picture, even though the animation quality is double what it is for a movie, technically speaking. And it has to do with like projectors and all kinds of technical stuff that has nothing to do with us. But from the very beginning, actually, the standard for video games was to render at 60 frames per second. The Nintendo Entertainment System rendered 60 frames per second. So the default in Unity is to render 60 frames per second. If your software is if you're asking too much of your system, it will knock down to fewer frames per second. So, update is called once per frame. So, yes?
Does the frame change from device to other?
Not for Unity, it doesn't depend on the device, but if the device is a potato, it won't be able to hit 60 frames per second, so effectively that individual device has a its own effective cap, but Unity isn't doing that to it. It's doing that because it can manage it. You know, if you took your potato and you installed a very high-end graphics card on it, you know, probably there would be another reason that you have 60 frames per second. But yeah, so analysis question. Update is called once per frame. What happens if your frame rate dips?
Relax.
Yes, the frequency with which the update function is called also lags. So, if your game is laggy, this will be laggy as well. This is why Unity provides another method definition, fixed update. Fixed update is used internally by physics calculations. This is fixed to 50. This gets updated 50 times per second, regardless of what the frames are doing. Does that make sense? So if you're doing anything with timing, or anything that's like time sensitive, fixed update is what you will want to use as opposed to update. But if you want something synchronized to individual frames, update is what you want, not fixed update. Does that make sense? Sort of? Hopefully? So, when we wrote the console applications, checking the time, okay. When we wrote the console applications, does anybody remember what line of code we used to print something to console? You answered the last one. Yes.
It was right line.
Yes, console.writeLine. Here, it's different. Debug.log. If we save that, and then run the program, I will now explain one more pane, the console. Oh, this is embarrassing. Oh, nah. Okay. I got it. All of you will get well used to this by the time you're finished with Unity. Any modifications that you make while the thing is in play mode are undone as soon as you exit play mode. So if you're going to make modifications, you must do it while the game is not running. I added this script to that object while the game was running. When I stopped the game, it unloaded it because it resets it to the state it was in when you pressed play. So I just have to re-add it. Then it'll work. And And you can do that as simply as drag, drop. There we go. And you can see, hello world. Make sense? So, start, again, executes once when the software starts up. Update executes once per frame. So you can see, if I put it in update, I get na 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 na. So, if you click collapse, it will tell you how many times that has been printed without actually scrolling through every single one of them. Collapse mode is awesome. So, any questions?
Cool. So,
one more for you. On application quit. Private void on application quit. Anybody care to guess when this one activates? Yes?
When you close it.
That's right. So, on application quit is when you close the game, and on destroy is that activates when the game object that you're working with is deleted. So, if I put a message in here, debug.log, goodbye. There we go. And I run it. I select the object to which this thing is attached, and I delete it. You can see goodbye. Question?
I kind of missed it. Could you look on this from an application?
Oh, excellent question. So, in a reasonably well-supported programming IDE, you can kind of just type the first bit of the name of something, and it'll ask you, do you mean this? And you just click yes, and it gives you the rest. So in this case, I just typed on. It gives me this list of things, right? Let's try on mouse down. That's a good one. On mouse down, or anything else. If you just click and if you just press enter, then it fills out the rest of it. Make sense? Yes.
So, before we were just printing text, that makes sense with Redline.
Good question. So the question is, like it made sense before because we were working with the console. Console.WriteLine, that makes some intuitive sense. What does debug.log mean? So first, Unity keeps track of a debug object. right? The console, the debug console is one of its responsibilities. So, for further information, consult the Unity documentation. So, if you ever have any questions about, like, if you ever want too much information on something about Unity scripting, I highly recommend the scripting API in the Unity manual. So debug is an object with lots and lots of properties. Something that we're going to be using, actually, is draw ray, or draw line as well, which allows you to, it allows you to draw a debugging line in space by specifying the start and end points, or the start point and the direction and length. But log is logging messages to the Unity console. So log as in keep a log, as in logging things to the log, as in ships log, stardate 3747332. Yeah? Make sense? Alright. Other questions? Cool. So, what this is an event system. That's what this is called. In software, the Unity system waits for some particular condition to be met. When that condition is met, it executes the corresponding event if you have defined it. Right? If I have a definition for on destroy, this gets activated when the game object is destroyed. There are a whole bunch of these. One of the more interesting ones is on mouse down. Other people call this on click. Debug.log. Ouch! So now, if you click, ouch, 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 ouch. So, and this is the this allows interaction between the pointer and world space in a kind of cool way. So, yes.
Yeah, on the on destroy or pass down statements, does it reference to doesn't do the method on that?
Oh, yeah, that's because you're in the wrong context. Put those inside the class definition. Indentation is important. When the IDE gives you suggestions about indentation, follow them. But that's like everything that's in this class has to actually be in this class. Otherwise, it's just hanging out in space. Basically, if you're not inside of a class, the only thing you can kind of validly be is a class definition in C#. But that's for another time. So this is how it works. This is going to get a little bit mathy, but I hope everybody's sitting comfortably. So let's say that we want to simulate, or we want to detect whether you have clicked on an object, right? So this is what happens. You have your camera, which projects its view out into world space. I'm going to do this in 2D because it makes it simpler. Let's say that you have some object. You want to determine if the thing has been clicked on, right? So during rendering, what the camera is doing is it's sending rays out, one for every pixel, seeing what it hits, grabbing the color of that, recording that back, and that becomes that pixel's color on screen. That's how rendering works, right? Clicking is a similar operation. So when we have the cursor, let's just do like a view of this, right? There's our sphere, right? Cursor is in green. So if our mouse cursor is lined up with our object, we know the X and Y positions of that mouse cursor on the screen, right? So, the camera knows that every pixel of the screen is so many radians of angle here, right? So it can calculate a ray corresponding to that mouse pointer. So if this is the base of the screen, like it isn't, but pretend it is, and our mouse pointer is like right there on the screen, using math, you can calculate a ray, basically a line between these 2 points, like that. This is known as ray tracing. If that ray intersects an object, then that constituted a mouse click on that object. If that happens, we run its on mouse down method. Conversely, if my cursor is not on the object and I click, another ray is traced, but because it does not pass through the object, it does not collide, the ray does not collide with the geometry of the object, this is counted as, a miss, and no method is executed. Does that make sense? Cool. So that's what's going on kind of in the back end on this. Any questions? Learning how video games work? If you study this stuff long enough, it'll completely ruin you for video games. Well, it doesn't really completely ruin you for video games, but at a certain point you do start just being able, you just see them as code, It's like, should have extended the hitbox on that guy just a little bit, eh? Someone was lazy with their bounding boxes. You ever play one of those games where this used to happen a lot on like old DS games, because not a very powerful platform, but it was N64 games as well, but to a lesser extent. You'd have level geometry, with bushes and a tree or something, but you could tell that all the game designer had done was just thrown in a quick plane to prevent you from walking in there, I'm sure we've all hit these types of boundary conditions, and you're like, but why can't I stand under the tree, game designer? There seems to be no particular reason why I can't stand under the tree. And it's like, no, my geometry must be simple. It's like, okay, but I'm gonna remember this and then complain about it in the class I'm teaching 20 years later, okay? So, I think the Pac-Man game for GameCube, Pac-Man World 2 for GameCube did that a lot. Anyway, it was quite common. Still, I'm sure it still is, but they try to hide that kind of stuff where possible. Anyway, so. So, let's see. Let's do if statements. So, C# programming constructs. It's all well and good to be able to write lines of code, but if you have no means of controlling their execution, you can only write very boring programs. There is a class of language constructs called control flow, or flow control structures, which allow you to determine how segments of code are executed and base that on the values in your variables, your bank of variables. So, the simplest and most basic of these is the if statement. How many have heard of them before? Anyone who has programmed has likely seen an if statement before. So, let's imagine our program flow comes down and we hit a decision. Is x equal to 5? Yes or no? Maybe if x is equal to 5, we print yay. Otherwise, we print boo. Right? This is the type of decision that you have to make frequently while programming. In fact, if you have any hope at all of becoming a programmer, performing this type of operation should become second nature. You shouldn't even have to think about it. So, but we're not there yet because this is intro programming. So we're going to learn how they work. Let's do this in Start. So the way that you encode an if statement does not vary much between programming languages. They all basically use them the same way. If x is equal to 5, whoa. I need an x first. Int x is equal to 5. Sure. If x is equal to 5, debug.log. Yay! else. Debug.log. Boo. Question. Is there a reason I'm using two equal signs?
Yeah, you have if x equal y.
Yes. What language are you used to again?
I've done C# and C++.
Okay.
I don't remember using, it's been a couple years though.
Two equal signs is a equality comparison operator. One equal sign is assignment. If you use one equal sign here, it will actually perform assignment inside of one of these, which is not what you want. You want a comparison operator. The comparison operator in most languages is two equal signs, except for stupid languages where it's three equal signs. Stupid languages being defined as JavaScript and PHP, as we will have more than enough time to explore next semester in 10,003. So, if you don't mind, copy that down and see if you can get it right, if you haven't already. Pay particular attention to the equal signs here. Make sure you don't forget your semicolons. If and else, make sure that you get your squiggly braces in the right places as well. It's very important what code is inside what block, otherwise it won't execute. Like it might compile, but it might not do what you think it should do. So. You can get away with that if that's only one line in there, but any more and you'll need the curly braces. You should be consistent. Either use them or don't, the curly braces. All right, your funeral. Working? Awesome. Working. That was it. Nice. That's awesome. Go to console. Console name. Right there. It's possible that the script isn't actually attached to the object. So, or the script isn't. Script. It thinks that script is blank. So what's this? You say that.
Oh, I see.
That's it. You gotta close. Closing? Can I show you that again? Should have taxed it. Oh, did you attach the script to multiple things? Yeah, it'll run once for everything you attach to it. Working? Awesome. I don't think we're gonna have time for F else today.
Yeah.
That's good. Yep, I think I've tortured everybody enough for one day. Sorry? Oh, yeah, question.
How many lines can I do?
One. Yeah. So as some of your colleagues found out, you you can actually remove the curly braces if it's only one line. And you can actually inline it as well, as it turns out. But if it's any more than one line, you gotta use the curly braces. Yeah. I know that the curly braces seem like they're a pain in the butt, but trust me, languages that don't use them are also a pain in the butt, but for different reasons, and sometimes the same reason. Anyway, so thank you very much for your time and attention, folks. Get out of here. Go. Have fun.